is Earth's only natural satellite. For a long time, it has appeared before our eyes as a gray, barren sphere covered with impact craters. The moon seems to be nothing more than a chunk of rock drifting through space. Compared with our vibrant, resource-rich blue planet, it was once regarded as a useless celestial body. Its surface is covered in dust and sand and was thought to hold no practical value. Humanity achieved a historic milestone by setting foot on the moon in the last century. Yet for more than half a century afterward, no one returned. It seemed as if the moon no longer held anything worth searching for. However, in recent years, plans to return to the moon have been relaunched at a rapid pace. This time, it is not merely a symbolic step. Instead, it has become an intense race among major powers, because beneath the seemingly meaningless layer of lunar dust may lie an energy treasure capable of determining humanity's future. In June 2019, a research team led by Peter James from Baylor University announced a shocking discovery. A massive, This discovery was quickly published in the world's leading scientific journal, Geophysical Research Letters, sparking widespread debate. Scientists believe that the mysterious mass may be metal or metal oxides left over from the crystallization of an ancient lunar magma ocean. What makes this discovery particularly significant is its potential connection to helium-3, a promising fuel for nuclear fusion. Helium-3 is extremely rare on Earth and is valued at billions of dollars per ton. If the moon truly contains abundant reserves of helium-3, a race to exploit and control the moon worth hundreds of trillions of dollars would almost certainly erupt. Although the moon is the celestial body closest to Earth in the solar system, human understanding of it remains very limited. Few people may realize that the moon's interior could hold secrets capable of reshaping human perception. It was not until 2011 that NASA deployed two lunar probes with the goal of creating a precise gravitational map of the moon. Why would scientists do this? Because a lunar gravity map allows us to explore the moon's physical composition and understand the distribution of density inside it, essentially performing a CT scan of the moon. During this gravitational survey, a major opportunity emerged. A research team from Baylor University in Texas, USA, analyzing the lunar gravity data, discovered a massive anomaly in the moon's south polar basin, concealing an enormous metallic mass. Previously, this area was thought to be merely a giant impact crater formed by an asteroid hundreds of kilometers in diameter. Unexpectedly, it appears to hide a huge metallic body. Could the asteroid that struck the moon have been a metal-rich planetary body, because the mass of this metallic body is so large that it distorts the moon's gravity in the region? Scientists believe the impacting object had a massive metallic core. After colliding with the moon's south pole, it became buried deep inside, forming a basin about 2,500 kilometers in diameter. If this enormous metallic mass could be extracted and utilized, it would be enough to support human civilization for tens of thousands of years. In the 1970s, the United States Apollo program carried out multiple missions that landed humans on the moon. Yet for more than half a century afterward, no American astronauts returned. Now, with the discovery of massive metallic material at the moon's south pole, NASA has once again begun planning lunar exploration and missions to send humans back to the moon. In the coming years, astronauts are expected to set foot on the moon once more. One of the main objectives of these missions is to explore the heavily cratered regions at the lunar south pole, because these areas may conceal extremely rich resources. However, exploring the moon is far from easy. The lunar environment is extremely harsh. Daytime surface temperatures can reach 127 degrees Celsius, while at night they can drop to minus 183 degrees Celsius. Inside permanently shadowed craters, temperatures can even fall to 240 grados bajo cero. The temperature difference between day and night is enormous. Moreover, the moon has no atmosphere to provide protection. It is constantly exposed to high-intensity cosmic radiation. Nevertheless, some impact craters contain large quantities of water ice, which is a crucial resource on the moon. And it can also be converted into rocket fuel, enabling the construction of lunar bases. Despite the moon's extremely harsh environment, this does not mean humanity has lost interest in it. On the contrary, after the United States began to feel uneasy, uncertain about what significant discoveries its rival might have made. The country has also announced an ambitious goal of sending humans to the moon before 2030. On the moon, in addition to other resources, there exists helium-3, which is extremely rare on Earth. Its importance lies in its role as a highly efficient nuclear fusion fuel. Just 100 tons of helium-3 could supply enough energy for the entire world for 1 year. According to scientists' estimates, the current value of helium-3 is about $20 million per kilogram. At this price, the moon's helium-3 reserves would be worth an astronomical amount. Although extracting and transporting it back to Earth remain major technical and cost challenges, more importantly, the economic value of helium-3 lies not only in its energy potential, but also in its profound impact on the future energy market. On Earth, helium-3 is extremely scarce. The total extractable amount is less than 1 ton, whereas the moon contains abundant quantities. It must be noted that helium-3 nuclear fusion technology is still in the experimental research stage and has not yet been commercialized. So how did helium-3 form on the moon? Lunar helium-3 mainly originates from helium-3 particles carried by the solar wind. Because the moon lacks both an atmosphere and a magnetic field, it cannot block the solar wind, allowing helium-3 particles to directly penetrate and become embedded in the lunar surface. In addition, minerals such as ilmenite on the moon have a strong capacity to absorb and store helium-3, making the resource relatively abundant. Earth, by contrast, is different. With its strong magnetic field and thick atmosphere, Earth effectively deflects and blocks helium-3 particles from the solar wind, preventing them from reaching the planet's surface. Therefore, whoever reaches the moon first and successfully exploits helium-3 will gain a critical advantage, essentially holding the key to future energy. This region is not only an ideal site for establishing a self-sustaining lunar colony, but also a cornerstone of the future space economy. Countries such as the United States and China are actively planning and carrying out lunar missions. Are so eager to establish permanent bases at the moon's South Pole. It is important to recognize that human science and technology are advancing every day. Once controlled nuclear fusion technology becomes mature, it will completely transform our way of life and significantly accelerate humanity's exploration of space.